Hello. Can I need a little bit of feedback. Shall I get started? Okay. All right. I was like those reporters that are waiting, like just with the microphone for like 15 seconds. All right. So let's do this. So this is going to be just a very quick update of what the Elixir team has been up to. So let's get started with the current version, the latest Elixir version, which is Elixir 1.16. And in this release, I think it came out 3 months ago about the big focus, and that's kind of generally the focus in our previous releases, has been the developer experience in two particular ways. So the first one is that we improved further the compiler diagnostics. So now, for example, if you have a syntax error, before we just said syntax error on this location, and then you had to go to your editor, figure things out. Now we show a quick snippet saying, look, here's the error, here's the snippet of the code, and whenever possible, we have like a caret pointing, like this is the thing that went wrong. We improved mismatch delimiters. So this happens, for example, when you start typing a list and then you close it with a curly bracket for tuples, right? So now you're like, hey, those things are not matching. You may want to look into this, and you can see that the error message is really nice with the snippet. Something that we also did for warnings and errors is that, for example, if we know that the warning was caused by a variable, we pinpoint like exactly the whole variable location. And the nice thing about all of this is that the way that we surface this information, we are surfacing all the way up to the build tools, which means that your editors will be able to pick up this information as well and show like it very precisely. Yeah, so we did that for warnings, we did that for errors. And in the worst case scenario where something happens, maybe there's an error in the macro and we can't exactly say what is wrong, then we are going to highlight the whole line. But generally speaking, we have these better diagnostics with snippets trying to be precise whenever we can, which is a very welcome addition. And it was mostly led by Vinicius Mueller. So a huge thank you to you, Vinicius. Another big change in Elixir 1.16 is that we revamped the documentation. So if you 6 months ago, if you went to learn Elixir on the website, we had like all the Elixir getting started guides on the website. And the thing is that when I wrote those guides, Xdoc, which is the tool that we use to generate documentation, did not exist, right? So I wrote and I put it on a static website, and Xdoc throughout those 10 years has improved a lot. So it was finally time to get all the documentation that we had on the Elixir website and bring it as part of the language, as part of the tooling. So now if you're going to get started with Elixir, right, you on the getting started material, it's now part of the official documentation, is in the same place, in the familiar Xdoc style. Then we can link everything. We have search, we have all the goodies that Xdoc provides. So all the official guides, they're now shipped with the language documentation. But we also use this opportunity to really bring the docs to the next level. We have always worried about documentation, quality of documentation, but in this release, we also added a new series of guides, for example, such as what are anti-patterns. So we brought a whole documentation of anti-patterns because, well, the guide is great at telling you what you should do, right? But sometimes telling you what you should probably not do is even more important, right? So anti-patterns describe common mistakes or indicators of potential problems in code. And this was work from it was PhD work from Lucas Veggi and oriented by Marco Tullio Valenti. So what they did is that they built an initial catalog of anti-patterns that apply to Elixir. So anti-patterns from literature, anti-patterns that we, the community, published in forums, published in blog posts. So what they did is that they gathered all this information. They built a huge catalog, okay? And then they documented it and they sent it back to the documentation. They said, hey, sorry, they sent it back to the community. Say, hey, community, we have this list of anti-patterns. Which anti-patterns do you think are important? Which ones are not? So they did a couple of rounds of feedback with the community. The community helped refine those anti-patterns, right? We got more feedback, and then they published their work. And now we finally merged that into Elixir, refining further the anti-patterns, getting a subset of those anti-patterns, and adding more documentation. Because the goal is that we want to have like precise anti-patterns. We don't want to have something that's like, oh, maybe this is not really an anti-pattern in this case. We want to be very precise, so it's clear and it's a clear contribution point that we're going to have to the community. And then you can check it out. There are 4 kinds of anti-patterns: code-related, design-related, process-related, and meta-programming related. You can check those out and see if you learned something new, if you figure out something that maybe you should not be doing, and so on. Something else that we did with the docs is that Xdoc has this amazing feature called cheat sheets. And we started defining cheat sheets. So we defined a cheat sheet for the no module in Elixir. This is most likely the largest module that we have in the Elixir standard library. So we defined a cheat sheet that you can even print, and then you can quickly learn what all the functions do and what they return and explore this API. Something else that we did related to the docs is that Xdoc has support for mermaid diagrams, and we incorporated that. So like in Jump Server now, if you go to the Jump Server page, you're going to see some diagrams of how a Jump Server usually works and communicate with clients. You're going to see diagrams showing how, when a client calls a server, what is the callback that's going to call in the code. So we have all those diagrams to this information that we had written in text. We had sometimes written in like type specs in callbacks, but having the diagram as another way of learning this is really going to help us master this too. So like there are diagrams for Jump Server, there's diagram for like what is the starting process of a supervisor. So we can all go more into depth into our APIs and tools. All right, so that's it for 1.16. So really focus on the developer experience. And what we are doing right now is that we are working on 1.17. That's the next release. It's usually about May that it comes out, a little bit after the next Erlang version. And so we kind of just started the work in here, but there are some things that I think it's nice showing that are exciting. So something that we added, I think it was last week, was the support for breakpoints in mixed test. And this one, it's better, it's easier to show. So imagine that you have a test to it, right? And there is a test failing here. So I'm running the plug test. There is a test that is failing. And you look at the code, you can't really understand why it's failing. So you have to debug it further. So you might know that if you want to run just a single test, you can copy this information here, for example, and say mix test, that particular file, that particular line, and that's going to run only that test, right? And now what you'll be able to do in Elixir 1.17 is that if you start your test with IEX and you pass the breakpoints flag, which is just -p, it's going to set a breakpoint at the beginning of that test. And now you can go like line by line, right? And start debugging, accessing the variables, and try to understand why that test is not behaving the way you expect it to. And the cool thing is that this B flag, it composes with any other flag. So imagine that you ran your test to it and 3 tests failed, and you want to like debug all of them, like one after the other. You can just pass -p and then -- failed. That's going to rerun only the failed tests, setting up a breakpoint before each of them. So really nice, really convenient feature coming the next Elixir version. Something that is currently being discussed, so a proposal was sent this week to the Elixir core mailing list, is to add a duration type to Elixir. So in Elixir, we have like calendar types. We have time, date, naive date time, we have date time. But Elixir does not have an API for handling durations. And that's because it's not as trivial as somebody may expect. So, for example, we know that 1 month does not mean 30 days, right? Some months have 30 days, some have 31, some have 28. Okay, so we have to answer questions like, well, what does January 31st plus 1 month mean? Is that 28th February or is that March 1st? Right? So we have to think about those cases. And even further, because the Elixir calendar types, they support different calendars, what does 1 year mean in the Chinese calendar? Because the traditional Chinese calendar, it's a lunar solar calendar, and some years have 13 months, right? So we have to be able to deal with this. So there is a proposal for adding support to a duration data type to Elixir, right? And the idea here is that you'll be able to say, I have a date and I want to shift it by 1 month, for example, right? And in this case, it's going to round down. So in this case, it's, well, we have a leap year, right? So it would be February 29th, right? And then we are going to add, basically, we're going to add a shift function to each data type. So we're going to have date shift, time shift, naive daytime shift, and daytime shift, which is even more complicated because if you want to shift the daytime, what happens that the time that you're shifting to does not exist because you are in a time zone that observes daylight saving time and they change the clock to 1 hour ahead, right? So there is 1 hour that does not exist. So what happens if you shift exactly to that point in time, right? So there are all those interesting questions, and there is a proposal tackling this, which also support multiple calendars and time zones. So check out the Elixir core mailing list if you want to give your feedback on the proposal and your thoughts. And yeah, and perhaps the question that everybody wants to ask and hear more about is the work that we have announced on set theoretic types for Elixir. So almost 2 years ago, I believe, we announced that there is a PhD scholarship to research and develop a gradual type system for Elixir. And the student is Guillaume Duboc, and it's being led by Giuseppe Castagna and myself. And last year, we published a paper with the results of our research, like with the design principles of the Elixir type system. And this was a very exciting paper because the challenge is that we have an existing language and we have existing type systems. How we are going to make like Elixir fit with an existing type system? And the type system that we chose is based on set theoretic types. But even then, we have to develop new theory of type systems in order to make Elixir work properly within this type system. So we can properly model Elixir in this type system. So we had a bunch of new research and key developments. So for example, we've modeled all the guard semantics under set theoretic types. We introduced a new form of gradual typing with strong arrows. We came up with literature with techniques for unifying records and dictionaries. By the way, when I say we, I mean Giuseppe and Guillaume, not me. Because, for example, just to give an example, unifying records and dictionaries, right? When we have maps in Elixir and Erlang, they actually have like two distinct use cases. So we use them as a dictionary, kind of like, oh, we can put like any key in it, like any string, right? So it's really a bag of things. But sometimes you use them as records, which mean like they have very specific keys that expect to be there. And usually the typing discipline treats those things as two separate data types. So how can we unify it? And we've published it, and there are articles being published. We wrote more on the Elixir website. And one of the things that we wrote last year is that the type system work is officially moving from research into development. And a couple weeks ago, I even showed an example. So in Elixir main right now, we already have the foundation for set theoretic types. And I showed one example of the warning that you get in Elixir main right now that is powered by set theoretic types. So for example, imagine that I write this code, okay, where I'm doing a binary matching. And then I say that X is an integer and X is a float. It's not possible for X to be integer and a float. So this should be a typing violation. Like this pattern will never match. Okay. So now you get exactly a warning, right? You're going to say, look, incompatible types assigned to X. And we detail exactly why that is incompatible, where the incompatible types are coming from, right? So that's work that is there already. But I want to say also that this is just the beginning. It's it's a lot of work. There's a lot of work ahead of us. But the roadmap, roughly, like for this initial milestone, is that we want to infer types from patterns and words. So we want to look at pattern matching. We want to look at words and say, oh, you have a word that say is integer or is binary. We are going to use that information to infer the types. And then we are going to perform type checking of language constructions, like accessing a field in a map, uh, bit string patterns, right? So all the language constructs are pattern matching itself, right? We're going to start performing type checking. And then we're going to start performing type checking across like functions in the same module, functions in separate modules. And the idea is that all this work is going to happen behind the scenes with no visible changes to the language, right? So the idea here is that we want to see if the type system implementation is efficient. We want to improve the quality. We want to make sure that we have really good error messages before we effectively change the language. Because if something goes wrong, and it can still go wrong, if you're not happy with this, we can just like remove all of it and say, well, not this time, right? We'll try again later. So, yeah, that's the roadmap, and this is possible only thanks to the partnership between the CNRS, which is National Center of Scientific Research in France, and Remote. And the development is sponsored. The development of the type system is sponsored by Fresha, Starfish, and Dashbit. So a huge thank you to those companies because it would literally not be possible without their contributions. So yeah, that's what I wanted to share for today, and thank you very much.
Thank you, Jose. We are going to try to take questions, and so that Jose can hear, because we think we have to stand near the laptop, I will just repeat your questions. And I'm trying to pull up the Whova app right now, which crashed on me. So we'll see if there's questions there. Anybody in the room have questions while I'm trying to restart Whova? Can you hear us, Jose? Okay, good. No hands? And no questions on Whova. You gave us all the answers, Jose, probably in that amazing documentation updates that have been happening lately. I, for one, am really excited to see the graphs and charts in there. I think I'm a very big visual learner, and that helps a lot in seeing what's happening. So thanks for all your hard work. Oh, I see a hand. Bruce. Is there anything included in the anti-pattern work for searchability?
So, Jose, the premise of the question is that sometimes I don't search for what not
So,
to do.
so he says the premise of the question is that sometimes he doesn't search for what not to do. So is there a way in the search to get those kind of results?
Yeah, sometimes we don't even search on what to do, right? We just stumble along. Yeah, so I think that's a very good question in how we can, for all documentation, all the work that we do, right? Which is um, how can we make that more accessible? Because there is like this there's like this answer that communities mostly they don't do anymore, but in the past they would do like read the effing manual, right? But it's like we cannot honestly tell anybody to do that. Like how many pages is all of Elixir documentation right now, right? And the Erlang documentation together. So I think the short answer is not really. Like we have a full text search and whatever that is, it may help find something. We have indexes for navigation, but 100%, that's not enough, and we should continue try to find new ways, right? So we are starting to explore things that can be AI related, right? Like what if you can have a AI model that knows better about the Elixir and the Erlang documentation, or it knows a little bit more about your project and your dependencies, and you could ask questions or review code. Like maybe what somebody should do is like get all those anti-patterns, feed into a language model, and say review my code according to those anti-patterns, right? And maybe something interesting is going to come out of it. But yeah, I think that's um, we've done the basic, right? There is indexes, there is search, but it's definitely a journey that we can do more, and we should continue like all continue exploring and trying to find more ways.
One in the back. What is going to happen to everybody's existing dialyzer specs? Is there going to be a way to convert them, or are they going to become useless?
That's a very good question. So yeah, so I gave a talk at Elixir conference in the United States last year that talks about the whole type system, and there is a long answer to why that is. But basically, the set theoretic types they can be more precise than our dialyzer types. There are things that you cannot do, you cannot express relationships that you cannot express with dialyzer today, but you can express with set theoretic types, and therefore and we want our types to be precise, because if our types are not precise, we can have like false. I always get confused if it's a false positive or a false negative, but it's a false something. So precision is important, and I think when we are writing the new types, we should really think like what is the most precise. So I think they will be we'll have to write the types again and think about the types again. And comparing to dialyzer, I think one of the things that is really interesting about this work is that what we are doing, because when I said, look, we're going to automatically infer the types from guards, infer the types from patterns, right? Which is something that dialyzer does today. But the difference here is that we are doing that within a full-blown type system. So it's kind of like, well, we have dialyzer kind of behavior within a full-blown type system, which means that if this works out, we will be able to include the types in the future with the semantic of a type system, which is not exactly how dialyzer behaves today, right? So, but yeah, the short answer is the dialyzer types, they can be a reference, but I don't think we should do automatic conversion. So please don't, community, don't write a tool for automatic conversion. I think it's going to be like a good opportunity to rethink the types.
All right, thank you, Jose, for spending your evening with us and hopping online. We really appreciate it. And everybody, we are out of time, so we have to go to a break. So maybe add questions in the Whova app or surface them to the community. Thank you, Jose.